Hey everyone, let's cover problem number 70. Right, so this is pretty much similar to problem 69, but we get cotangent squared minus cotangent x. So apparently we get some cotangent, and we're not really comfortable with cotangent, but we're going to deal with cotangent anyway, because the think through process, the stuff that I wrote down for you guys to help you out, actually have t equals cotangent x. So let's just try to see what has happened, right? So first off, the very first idea that we need to know, let's just try to erase it. T equals cotangent x. And we can sketch the graph. We can literally sketch the graph from 0 to pi. And except at pi, we get the vertical asymptote. And this is going to fall, right? You can tell that this is going to fall with the slope of -1 at that moment at pi over 2. And this is a nice looking function. It's a decreasing function. It's well defined for 0 to pi, not inclusive. So yeah, this is well defined. As long as we don't get anything about like 10 t equals 0, we're going to be fine. Okay, well, we're going to be fine even for t equals 0. We're not fine when we have to deal with those t equals something like tangent x, right? Anyway, we get t squared minus t equals 0. So that means this is exactly the same thing as cotangent. Cotangent squared minus cotangent x equals 0. Right. So you can simplify. T times t minus 1 equaling 0. What does that mean? It means that, hey, t is going to be 0 or 1. Right. So t is going to be 0 or 1. The question was asking us to find out the number of real solutions. Thankfully, we don't have to worry about the exact value. But in this case, we can find out the exact value too. But, forget about those finding the exact value. Let's just try to find out what cotangent x equals 0 or 1 means. Well, what this means from our graph. It means that you need to sketch the horizontal line at y equals 0, or let's say t equals 0. And you need to draw another horizontal line at t equals 1. Now, t equals 1. And I can tell you that we get one point of intersection and the other point of intersections. So we have found two points of intersection within 0 and pi. And all those points, I would say, have nothing against the domain, right? So that means that we get 2 points of intersection. Is this coincidence that we keep getting 2? Well, I don't think so, but we get 2 points of intersection for this problem as well. So the answer for our problem again will be 2.